so problem 4.9, let b sub 0 be an integer number and b sub n belong to this set 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, from 0 to 9, from all natural numbers. Okay, and form the series, the sum from n equals 0 to infinity of b sub n over 10 to the n, right? And this is equal to b sub 0 plus the sum from n equals 1 to infinity of b sub n over t to the n. Okay, and I'm separating these two things because b sub 0 does not belong to this set. Okay, so it will be made clear later on. Okay, so first question, prove that this series is convergent. Okay, so we need to prove this is the sum of a number, right, an integer number, plus this series. So we need to prove that this series is convergent now. Okay, b sub n over t to the n. Now b sub n, all of the b sub n's are smaller or equal than 9. Okay, or you could say smaller or equal than 10, for instance. Okay, so smaller or equal, let's see, than the sum from n equals 1 to infinity of 10 divided by 10 to the n, right? So this is equal to the sum from n equals 1 to infinity of 1 over 10 to the n minus 1. Okay, so when n equals 1, this is 1, and so we could rewrite this, and please prove this at home if you're not sure that these two things are the same. Now this is the geometric series with parameter 1/10. Okay, and so we know this is smaller than 1, so we know that this is equal to 1 minus 1/10. This is 9/10, so 10 over 9, which is smaller than infinity, right? So the sum, this series converges to a finite value. Okay, now the second part, so this is using the comparison test, right? The second part is to discuss the meaning of this series and why this is so important. Okay, so this idea, let me see, give you any number to, so suppose you have this number, for instance, let's say it's b sub 0 is 3, then b sub 1 is 1, b sub 2 is 4, b sub 3 is 1, b sub 4 is 5. So if we expand this series, okay, we have b sub 0 plus the sum from n equals 1 to infinity of b sub n over 10 to the n, and then we have 3 plus 1 over 10 plus 4 over 100 plus 1 over 1,000 plus 5 over 10,000 plus and so on and so forth. So this is 3 plus 0.1 plus 0.01 plus 0.001, so this is 4 plus 0.000 yes, 5, right, plus, so we can get these two things together, and this is 3.1415 blah blah blah. So this is a real number. Okay, this is actually the first decimals of pi, and so what you see is that every term in the series is actually the next decimal in the real number. Okay, so in other words, the term of this sequence b sub n are the decimals in the decimal expansion of a real number. Okay, so that's interesting. This series converges to an actual real number. Okay, and so this means that we have proven that the expression of a real number in terms of its decimal expansion is actually a formal equivalence. Okay, so it's not just a compact way of writing this. This is actually convergent to this. Okay, so that's a very interesting thing. Okay, so let's go for part C. Calculate the sum for b sub n equals to n for all n greater than 0. Okay, so we have b sub 0 whatever, and then we have b sub n equals n for n greater than or equal than 0. Okay, no, sorry, so then b sub 0 is also b sub 0 is also 9, right? So then we have the sum from n equals 0 to infinity of 9 over 10 to the n. That's the sum. So then we have 9, the sum from n equals 0 to infinity of 1 over 10 to the n. But we computed this already here before. This is 10 over 9 times 9. This is equal to 10. Okay? So that means that, you know, this expansion that we have just said, it's the same as 9, okay, the first term, and then 0.99999, all of 9s up until infinity is the same as 10. Okay, so this decimal expansion periodic terms 99999 is equal to 10. Okay, and it's also true for, you know, 0.999 is equal to 1 and so on. Okay, and then fourth part D, asks us to calculate the sum if b sub n is 1 for n even and b sub n is 2 for n odd. Okay, 2k plus 1, where k starts at 0, 1, 2, blah, blah. Okay. Now, what does this mean? What's this number? Well, this is 1.2, 1, 2, 1, 2, 1, blah, blah, blah. Okay. Okay, this number has a periodic expansion, as you can see, right? 2, 1, 2, 1, 2, 1, and it repeats. So that means this is going to be a rational number. Okay, so this is equal to the sum from k equals 0 to infinity of 1 over 10 to the 2k, right? Plus the sum from k equals 0 to infinity of 2 over 10 to the 2k plus 1. Okay, so separate the sum in two parts, the even and the odd numbers. And so this is the sum from k equals 0 to infinity of 1/100th to the k, and then we have 2 and an extra 10 here, times the sum from k equals 0 to infinity of, and it's the same sum, right? 1/100th to the k. Okay, so this is 1 plus 1/5, okay, times this sum, okay, which is 1 divided by 1 minus 1 over 100. Now this is 1 minus 1 over 100 is 99 over 100, so we have 100 over 99, and then we have 1 plus 1/5 is 6 over 5 times 100 divided by 99. Okay, so then we have 100 divided by 5 is 20 times 6 is 120 over 99. Okay, so this is the decimal expansion of that rational number. Okay, and that's the end of the exercise.